This conference will now be recorded.
So thank you, everyone. This is Archana Haylock with the OCP Foundation. We sincerely apologize for the last minute change around and really appreciate everyone jumping on the call here between Shin and Rita and LinkedIn and everybody there. Really appreciate the fact that they were able to help us get this meeting so quickly online. With the global summit being canceled due to the risks and the impact of the coronavirus, we've had to get really creative with how we're reaching out to our audience. So really appreciate the fact that everyone's taken their time here to do this. I wanted to open it up with just a brief talk about OCP and where we fit in. With the SONiC project. The SONiC project has been one of our largest growing projects with, with Microsoft at the helm. And I'm sure all of you are already familiar with SONiC because you've been hearing about it either on the OCP website or on the SONiC project calls. If you aren't on the mailing list for SONiC, please work with Shin to get on the mailing list. That is our main form of communication to talk to the audience. She's managing that entire mail reflector. That's the way we communicate project information, call information, any reschedules, as well as that reflector is used for a lot of the challenges and conversations that occur during the call. So a lot of the activity is there. So if you haven't joined the mail reflector for SONiC, please do so. We will post the link for it here in the chat shortly. And that way you can also go on and take a look there. Other than that, if you have any questions regarding OCP, I'm not going to take up precious time here because we do have a very packed agenda, as you can see on your screen. It's going to take us all the way until almost 5 o'clock here. So I will post my email as well as Michael Schill's email in the chat as well. And if you have questions about the foundation, about membership, about how to get involved, we will go ahead and answer those on an as-needed basis. But you can always reach us. We're local here in the Bay Area. Michael's in Chicago. Our phones are always on. And of course, you can also go to the website for any specific details. But that's pretty much where we stand. With that, I'm going to turn it over to our two wonderful organizers here, Shin Lu and Rita, and also Zheng Yu from LinkedIn is here as well. So the three of them have crafted an amazing agenda for you today, and we'll navigate you through the rest of the day. So with that, Shin and Rita.
Yeah, thank you, Archana. Let me share my screen. Can you guys see my screen?
Yes, we can.
Yes.
Yeah. First, thank you, Archana, Michael, and Kelly for quickly help us out. This happened on Friday during the weekend. Find the bridge, which one to use, and how to organize this. Thanks a lot for OCP again for hosting all this. Second, I would like to thank LinkedIn, which has been prepared this event for a long time. These actually are the souvenirs they prepared for everyone. You can take a look and imagine it's with you. So, with that, I'm going to get it very quickly to set the expectation and how this is organized in these 2 days. So majority of you will participate in day one, today's meeting, which the agenda we will repeat it, we will show it after every presentation. So each talk will be around 20 to 25 minutes, 5 minutes Q&A. We have to keep this very tightly controlled because of sometimes online discussing could go very long. That's good, but for today we have many talks lined up, so we have to have a good time control. But for tomorrow, there are two small subgroup discussing going on. One is the test subgroup. The agenda is here, also listed on the Eventbrite. The meeting bridge, it has been posted. In parallel, the SAI subgroup has a bunch of topics going on, for example, VOQ, SAI security, MPLS, and mirror drop. Those two sessions we are going in parallel tomorrow. People who has registered for those events have already gotten the invitation. So these two events are for smaller subgroup. Then coming back to today, we will go through this agenda for the technical talks. We received a lot of requests and interest sent to the committee. So those are the topics we picked so that it can help to shape what we are going to do in the rest of the year. With that, let me see if the first person has arrived.
Hi, Xin. This is Heidi.
Okay, Heidi. Thank you for being here. I will make you the presenter, but since we are ahead of time, let me pause it here. Any questions from the audience? Do you know how to raise a question for the audience? This is our first time to go fully mutual with such large number of audience. So we would like it to help everyone. You have two ways. One is just to unmute yourself to speak up. Second is to type in the chat window. We encourage you to speak up because the chat window, we might miss it, but we are monitoring the chat window. Second, if you are not a speaker and you are not raising a question, we appreciate that you mute. Okay. Third, this session will be recorded. And the fourth, if you are not a speaker, I hope you can turn off the camera. Yeah. Okay, with that, we are going to give time to Heidi to start the first presentation.
Yeah, I'm going to share my screen here. Okay. Can you see my screen?
Yes. Not yet.
Yeah, not yet.
Okay.
For non-speaker, we appreciate that you can turn off your camera. Yeah.
Sharing application, your entire screen. Application windows.
Let me try again to make you.
How about now?
Yes.
Yes.
Okay,
Perfect.
Great. Okay, let me make this a slideshow. Okay. Yeah. Hello everyone. I'm Heidi Oh from Alibaba Infrastructure Service. It's very nice to meet you all virtually, though. Because it's a quite an experience to remember for OCP. Yeah, let's start. In Alibaba, we have been working on SONiC since 2017, if I remember it correctly. In the past few years, it's amazing to see the community growing so fast. And SONiC itself has been widely on a massive inside data center. Today, I'd like to share with you some use cases of SONiC in data centers. It's very interesting because Alibaba and its customers have a user base with hundreds of millions of users at peak demand. I'm also discussing the exciting future as well as the challenges if we want to extend SONiC beyond data center. Yeah, first let's take a look at the most popular SONiC deployment today. It's the classic 3-layer class topology within data centers. From the bottom to top, we have TORs, which is connected to a lot of servers. Then up to leaf until the spine. The baseline unit is simple and straightforward. Then we just duplicate this baseline units hierarchically and multiple times to stack up to form a huge data center network. Even though the 3-layer class topology itself is simple, but the number of nodes are huge. So when things goes large, there are complications. For one, it's a challenge for the network operators to monitor and manage such a large number of switches. As usual, when the system gets big, you build another system to manage it. So we have been investing heavily to construct our own network management system to manage SONiC nodes in the network. But on the other hand, we don't want to make each node too complicated. Rather, our goal is to keep each node as simple as possible. Now, look at each node in the data center. In terms of scale, currently the number of routes on each switch is within the range of 10K, like 10K, 20K. And the number of BGP neighbors is around 100. We do have a lot of important features for the data centers, such as ECMP, warm reboot, INT, gRPC, and many others. However, we don't need to have all features. For example, there's no IGP, such as OSPF, ISS, EIGRP RIP, and no MPLS. And my favorite, no multicast, which is upside down when compare with unicast. As I mentioned above, we have committed and invested a lot in SONiC. And naturally, we want to maximize the return from our investment, including the deployment effort and testing effort, especially the effort in network management. Ideally, we should use one system to manage all nodes. So we are trying to figure out where else we can deploy SONiC to leverage and reuse our experience besides the 3-layer class switches. Let's look at the topology of a typical internet company. On the bottom, there are data centers marked as IDC in dark green. And VPC service is provided inside the IDC. And in order to connect it to the VPC, some customers may use dedicated line, a kind of backdoor connection to access switch. Here it's marked as ASW. Then a bit up, IDC is connected to the metropolitan switches. We call it MSW. And further up, metro switches are connected to either internet via internet connected router, or connect to its own backbone network via the backbone router. So look at the topology. A natural thought would be some switches, such as the access and metro switches, could be a potential candidate to run SONiC. But we need to add or adjust in order to extend SONiC to those nodes. Here let's use the access switch as an example. Zoom in a bit to take a look at the area around the access switch. It is used to connect a customer DC on the right-hand side and to the public cloud, so that the customer can move data between its own data center and the VPC. The link here between the access switch and customer CPE could be an RSP or via a dedicated line from POPs. So if we want to run SONiC on access switch, it will have to support 3 types of connections from the control plane. First, it's the CPE, where the subinterfaces are usually required. The reason behind that is multiple customers, they may share the same physical links. For example, like 20, like less than 1 gig bandwidth. Or one customer, they can sublease the one physical link to its own customers. So on the subinterface, it's usually encapsulated into either 2.1Q in layer 2 and WRF in layer 3. Of course, for the customers demanding high bandwidth and could just run WRF on the main interface. Then the BFD is required. We will discuss this more later. The next connection is to the controller. They exchange MPBGP in order to install routes in each WRF. The last connection is to VPC and via the VXLAN, and EVPN usually used there. So on both the CPE link and the VPC link, we need to have a bandwidth control. We will discuss more in the next slides. Let's look at the features we will need. First, the bandwidth control via the traffic policing. When the traffic comes to the access switch, we have to control the rate based on SAI contract. This is dollar driven, depending on what the customers are willing to pay. And when the leaves the access switch and goes to the cloud, we also want to do the rate limit. Note that traffic for one customer may come from different ingress interfaces and goes to the same interface. And yeah, sub-interface, as we mentioned in previous slides, the rate limit may be on sub-interface when the physical link is shared by multiple customers. We may also want to apply the traffic shaping for some customers. Yeah, this is interesting. Dynamic configuration is unique to the access switch. Unlike switches in data center, where a node normally gets configured and run forever, and unless something's wrong or upgraded, we normally don't change the configuration on the switch. But the access switch customer, however, they may want to add, delete, or update the connection frequently. When big events occurs, for example, before the single day shopping festival, there are usually lots of requests to increase the bandwidth. And after the event, we received tons of requests to reduce the bandwidth or even remove the connection peering. This will require the operator to be able to dynamically change configuration while not interrupting the traffic. Also, the customer, sometimes they want to know the bandwidth usage, and based on that, do their own analysis in order to plan their network. So for us, if we can use data to optimize for customer when they order bandwidth and also provide data to help the customer plan their network, it will be a win-win business. Some other features, like access switch may not have many local XMP link as switches in data center. Where one link goes down, the traffic can switch to other passes. This can be even done by ASIC. But on access switch, since we don't have so many XMP, we rely on BFD to achieve fast convergence on control plane. And to avoid flapping, BFD damping is enabled. Also, current SONiC provide Docker level warm reboot, while on BGP Docker, we do graceful restart. However, this conflicts with BFD. So in order to achieve the balance between those two use cases, we have to extend the BGP dynamic capability, which is documented by IETF draft. Yeah, since we said a controller is connected to both the access switch and the VPC gateway, to make sure the routing and forwarding decision based on the network status, BGP is enabled between the controller and the access switch. Between access switch and the VPC gateway, traffic is encapsulated into VXLAN. The remote VXLAN information can be either learned dynamically by EVPN or by static configuration. The reason for static configuration is mainly for incremental deployment consideration, as the remote gateway may not be able to run EVPN. Yeah, multicast, we try to get rid of it, but in some special case, IGMP for multicast may be needed. Now let's look at the scale-up factors. Access switch, the number of connection depends on the number of customers, including customers on the sub-interfaces. So we are looking at extend BGP neighbors from around 100 to 400. And all BGP sessions will be running on BFD. Monitoring all BGP neighbors and routes change, as well as the bandwidth usage, then feedback this information to our customer is a difficult task. We may have to combine BMP and periodic pooling from gRPC to accomplish this. Now, let's take a look at the metro switches we mentioned earlier a little bit. It is used to connect the data center spine layer to the backbone routers. It pushes up the routes from current 10K range to 100K, and with large number of ECMP paths. And in terms of features, things is close to core, which usually have traffic engineering enabled. It's possible to include metro switches into the PE network, which means MPLS support. So, just summary, like we have a lot of experience in developing and deploying SONiC inside data center. While enjoying the success of the SONiC in IDC, serving hundreds of millions of users, we are also aware of its limitation as well as its potential. So we are confident that deployment of SONiC in IDC should be accelerated. There are heavy investment on network management, and we have designed it as unified network management with an eye on extending SONiC beyond IDC. So as we discussed earlier, SONiC can be extended to access and metro switches. It will be new and unique challenge. So in that process, namely the growth of features, scalability, and network management, etc. But armed with the experience and the success of SONiC in IDC, we are confident that we can adapt SONiC to new area beyond IDC. So yeah, so that's conclude my presentation. And any questions?
There's some background typing. If you're not talking, can you mute your keyboard?
This is Dean. I have a quick question, Heidi. What is the current deployment size and scale of SONiC within Alibaba network? Can you give us a quick update? I think I see a little bit in your slides here and there.
You mean inside the data center, right?
Yes, inside data center.
Yeah, the number, I'd rather keep this as business confidential. But what I can say is it's a significant part of a data center. And most important is the growth rate. It's huge.
Okay, all right, it's significant. Thank you.
Yeah.
Hi, quick question. You mentioned there's INT features being used. Could you briefly tell us, what kind of features are being used?
Yeah, we have been actually since 2 years ago, we have been working with a lot of few chip vendors. because there are very active development in that area. If you look at the INT, what kind of functionality they can provide, right? You can insert any information into the packet and give you do a lot of diagnostic on the networking. So we mainly do right now. We have some features need like RDMA. They need to make sure no packet drop, basically no packet drop. And the only way to achieve that is for us after study, we think the INT is the best way to achieve that. So we do work with like a server and the side and try to basically, if you look at the INT, it's a big idea. It's insert information into the packet, and then they can translate this to the monitor and to monitor the whole network, the health of the network. So we have some application-specific information to be inserted into that field, then do more network monitoring.
Hi, Heidi. This is Sabi from Juniper.
Hi.
Hi. I have a question. Do you see the need for SONiC on a distributed chassis in any of these roles? Or do you think it's going to be beyond at the border router or internet routers?
Yeah, I can see some potential use case, but in the long term. But right now, we don't have. We are open our eyes, open our mind to try to talk to some other community members in this area. But in terms of deployment in the short term, I don't see that.
How about within the data center itself at the higher tiers?
Not in the short term.
Okay, thank you.
Hey, this is Naveen from Broadcom. In one of the slide I saw you mentioned 10K BGP routes. Is that all we are expecting in this data center?
I mean, in the range of 10K, it may go to 10K, 20K, giving if we have both IPv4 and IPv6.
And what's the maximum scale we are looking at? Max routes?
Right now, it's if we think the data center, we're looking at about like maximum probably 40K.
Okay.
But yeah, if we want to push that to 4 router, the number will definitely grow.
Hey Heidi.
Hello.
Okay. I don't think they can hear me.
Yeah, I can hear.
They can hear you. There are 2 people actually on the call right now. Looks like
they can hear you actually now.
Okay, so Heidi, you mentioned, you talked about your investment in network management, and particularly you talked about unified network management. Can you tell us a bit more about your developments there and what you plan to contribute, and how does that relate to the work that Broadcom and Dell have been doing on unified network management with GNMI and REST?
Oh yeah, that's actually, it's a very good question, and the answer could be very complicated. If you know the history of a lot of internet company and in China, and they have their like management system built up because the network grows so fast. They have the management built up in multiple ways. We can put that like this. Probably like in the core network, they have some tools, and for the data center, they have some tools, and in the metro network, they have different tools. There are so many vendors there, and like Juniper has its own configuration, and Huawei and Cisco. Like even within Cisco, it has different operating systems, and the way to configure the box are quite different. So how to unify all this? And we don't want to develop like one management system for one vendors. So we are forced to build up our own management system. But still, the first step is that we try to unify and build up the API to talk to different vendors' boxes. And also, like, that's the first step. Then the second one, like you have some customers, they ask the information to feedback to the example I gave for the access switch, right? They ask what's the bandwidth usage, what's the BGP like routes. So we have to feedback this one to them. And that gave us a more challenge how to build up the whole systems. You can keep some part in your network and share some information with your customers. So in order to do that, we have to rebuild our whole management systems. And of course, SONiC provide very unique technologies like gRPC, which right now probably not supported by all the vendors, or not all the boxes provided by all the vendors. If we can use SONiC deploy SONiC in most of our boxes, we can take advantage of that. So that we keep that in mind when we develop our own systems for the management systems.
Okay, so am I right in thinking that when you talked about the unified network layer, you're really talking about something that runs off box, that runs at the south end of the NMS, right? Not something that runs on SONiC. Is that correct?
Right.
Okay. So what do you think about, obviously what we're trying to do for SONiC is to drive management standards using open config. What do you think about that as a moving forwards in a more integrated way?
Yeah, it's we do keep eyes on take a look at that. However, it's we have an operation. They have to do the business every day. They cannot wait for converge everything because they have to do their daily operation. But we do look at the management work from the community to say what's the best way to integrate into our systems. It's just it's more like midterm or long-term project for us. But for some online business, we have to keep it running.
Okay, thank you.
So I think that was our last question. If you have any other questions, please either send us an email or put something in the chat, and we can follow up with you shortly after.
All right, thank you.
All right,
Go
ahead, Shane.
Yeah, thanks, Katie. Yeah, thanks, Archana. So we are ahead of our schedule by 10 minutes. Let's give it a break. The next schedule I'm presenting is here in case other people miss the talk or the speaker hasn't arrived. So can you guys see my schedule? We finished number 1. Now the next one is Praveen from Cisco. We will start at 10:30, but to keep the original schedule so people looking at the web knows how to participate or when to participate. Meanwhile, we will work with Praveen to test his screen share and the audio. Yeah. Thanks. Hi, Praveen. Are you online?
Yeah, I'm online. Can everyone hear me?
Yes, we can hear you right. Yeah.
Okay,
Also,
can you just pass me the presenter role? So let me just make sure that I'm able to share.
definitely.
Thank you. Okay, can everyone see the presentation?
We are able to.
Okay, all right.
Okay.
So we can, as you said, we can probably wait for a few more minutes to get started, right?
Correct. Well, meanwhile,
Fine.
I would like to get the rest, like the other two presenter also ready. Juan Jose and Bhaskar, can you speak up to check your audio? Hi, Jose. From Dell.
Hi, Shin. This is Bhaskar from Broadcom. Can you hear me?
Yes, very good.
Hey, this is Senthil from Dell. Can you hear me?
Yes, very good. Okay. So who will from Dell will present? We have two speakers.
Yeah, Jose will be joining me shortly here from Dell side.
And who will be sharing the screen? Is that?
No, we can show the screen. I will share the screen then.
You will. Okay, great.
Since when you are talking, there's some echo at the background. Maybe this is a good time for you to check a little bit.
Okay, we are in a conference room. Let me see what we can do.
Okay. And as the next, just as a practice, Bhaskar, I'm going to make you the presenter. You share your screen. Now that's just to check logistics.
Okay.
We have muted it, but we still hear the echo. I think it's somebody else.
Jin, the echo might be coming from you actually.
1 second. Okay, Bhaskar, we are able to see your screen. Very good.
Okay. Okay, great.
You can stop sharing. So the next one, I will make Dell as the presenter. Hi, Cynthia, I think I made you the presenter. Did you see it?
It showed up, but it's not popping out for me. I am just saying, ask if we can share the screen. Your request has been sent is what is coming up.
Okay. Okay.
Yeah.
Okay, we can see your screen.
Okay, the echo is not there now?
You are showing open for all, right? Can you go one more slide?
That's correct. Yeah. So are you
Excellent.
able to, the echo is also reduced, right?
Yes, very good.
Okay, thank you.
Okay, yeah. Can you stop the sharing now? So again, what we are looking in this morning is we have 4 sessions. The next one will be from Parvin from Cisco, followed by Dell, team with real-world experience of hardened network SONiC implementation. The last one will be from Bhaskar from Broadcom on board-view-enabled telemetry. With that, I'm going to enable Parvin as the presenter. By the way, we received notification that 150 people max has been reached, so the newcomer won't be able to join. If you have colleagues asking these questions, please pass around the word.
Jin, another thing that can be done is if people are, in a same conference room and I have dialed in, maybe they can only one person dial in from a conference room so that there is an opportunity for others to join.
That is a very good suggestion. Thank you. So I would encourage enterprise users try to group together so that in the conference room, so that more people enable more people to join. Apparently, I know that more are trying to join, so they got delayed. Second, if you are trying to ask a question, can you please speak who you are and which company you are from? Yeah, and then followed with your question. Yeah, thanks. With that, we will be prepared for Parvin's talk in 2 minutes. Okay. Hi, Parvin.
Hey, can you hear me okay?
Yes, very good. So
And can you also see the, can everyone see the presentation as well?
Yes.
Okay, wonderful. Should we get started?
Yeah, let's go.
Okay, all right. Hello, everyone. Good morning, good afternoon, good evening, depending upon where you are. My name is Praveen Bhagwatula. I'm a fellow at Cisco, working in the service provider routing organization. First of all, thank you very much for the organizers for this opportunity, and great job in very quickly changing this the logistics of this meeting. I know it's not an easy task to do that at such a short notice, so kudos to the team. What I wanted to essentially discuss today, and this is a very interactive session, so please ask your questions. I'll try to leave like at least 10 minutes at the end of the call for Q&A. What I mainly wanted to focus on in today's presentation is two quick things. The key aspect of the conversation I wanted to discuss is how do we take SONiC that is gaining so much momentum today within the data center, and I know as we just discussed outside of the data center as well, how do we take that and run that in large modular chassis with multiple NPUs, multiple line cards, all packaged together into a single chassis, which has traditionally been managed and run by network operating systems like vendor network operating systems from all the traditional networking vendors. So that is the crux of the conversation. But before we jump to that conversation, I wanted to give a quick overview because this is related to the work that we are doing on enabling SONiC on a modular system. Wanted to give a brief overview of the NPU family and the systems on which we are doing this work. So as some of you might know, Cisco has announced a silicon called Cisco Silicon One, and the first incarnation of that called Q100 back in December, and a set of platforms, both fixed and modular platforms called Cisco 8000, based on this silicon. There are a couple of elements that I wanted to highlight about the silicon, which we would again come back to when we are discussing SONiC on in a modular system, and this context is important. So the first thing is that this is a single device which is capable of 10.80 in its current incarnation, but this is a device that can actually work in for three roles. One is as a regular NPU or an ASIC in a fixed form factor system, the typical 1RU, 2RU fixed form factor boxes. It's also used, which is essentially like what we call as a system on a chip, right? In addition to that, it's also used as an ASIC or an NPU on a line card in a modular chassis. And the same silicon is also used as a fabric element in a line card system, in a chassis-based system, and I'll get to that in a bit more in just a minute. So essentially, the exact same silicon with a different software load can play these three roles. And the other interesting aspect of this is it has both a large, on-die SRAM for forwarding resources like routing tables, all the interface classifications, and so on and so forth. And it also has a buffer expansion via HBM for deep buffer type of application. So wherever there is need to have deeper buffers for traffic, it also enables an optional expansion of the buffers using HBM. And it also has a inbuilt TCAM and memories for all the forwarding resources. There are two like broad form factors of systems that are being built using this. One is obviously what we call a Cisco 8200, which is the system on chip fixed form factor systems, 1RU and 2RU boxes. Not as much interesting for today's conversation, but just as a context. And the one that you see on the right here are the Cisco 8800 series, which are the different sizes of modular systems. And that's where the crux of the conversation that I wanted to have today focuses on. In terms of enabling SONiC on these platforms, we are basically working on enabling SONiC both on the 8200 platform, which is a system on chip type of a platform, single NPU, single CPU, and set of optics. So that kind of represents the, obviously there are fans and power units and LEDs and everything that's needed to build a typical switch or a router. In this model, the SONiC implementation is relatively straightforward. We take, the basic SONiC, the Debian Linux, run it on the system, provide the platform plugins for managing the platform components, and there is an SDK that is built on top of the Cisco Silicon One, and that SDK is basically used to map from the SAI APIs into the hardware. So it's a pretty standard model of enabling SONiC on a new platform, on a single system, on a chip type of a platform. Just to kind of repeat what I said, two major functions that need to be provided by any new platform. One is the mapping from SAI APIs into the SDK, and the second one is the platform plugin. So this is a relatively straightforward implementation that we are working on to enable SONiC on the fixed platforms. Now, as I mentioned, where it starts to get interesting is when we are addressing use cases to enable SONiC on a large modular system. And this large modular system, obviously there are two, there are already there are already models to build these large modular systems, like using the six-pack backpack models that we are all aware of. The fundamental thing that differentiates, what typical routing part of the world uses for the modular systems is the fact that one, these are debuffered ASICs that go on to the line card systems, and the second one is the systems are typically built with a fabric element which traditionally forwards the packet based on virtual output queues, right? Rather than treating these packets within the system as hop by hop, packet by packet switching type of systems. If you look at any of the traditional large modular chassis from any traditional networking vendors like Cisco, Juniper, Arista, and others, these are typically built. The fabric elements are typically built with ASICs that do either cell-based fabrics or packet-based fabrics across the backplane, and that is, there's a whole set of reasons for why systems have been designed the way they have been designed in the past, right? So if we decompose any modular system, typically not just the Cisco 8000, but if you look at any modular system, typically if you decompose it, it primarily consists of three parts. There are a set of what you call as route processors, which is basically where the bulk of the management and the control plane software of the system runs. So this is typically where all your management agents like netconfig run, all the telemetry components would run. This is where all the routing protocols like BGP, ISIS, and others would also run, right? Then there are line cards, which are predominantly used for collecting all the network I/O, right? This is where you have all the different type of optics, different form factors of the optics, and so on. And the line cards are where the packet forwarding NPUs or ASICs are hosted. It could be one NPU per line card. It could be multiple NPUs per line card, depending on what type of optics are plugged in, how many of those types of optics that are plugged into the system. CPUs on the line cards are, again, optional components. There are different chassis designs with and without CPUs on the line cards. And the third element is the fabric cards. The fabric cards are typically used to interconnect the line card. So think about them as spines within a, like if you basically fold a leaf spine network into a single enclosure, the line cards, quote unquote, become the leaves, and the fabric cards, quote unquote, become the spines. So if you can imagine, putting a large sheet metal around a leaf spine fabric, right? That's kind of how a chassis-based system typically decomposes to. Traditionally, the ASICs or the NPUs that are used on the line cards are very different from the ASICs and NPUs that are used on the fabrics. And this is predominantly based on the functionality that has traditionally been required on the line cards and the fabrics. So the one unique factor, which will again we'll discuss as to why that plays a role in the Cisco 8000 system, is the fact that it's the same NPU that goes both onto the line cards as well as onto the fabric cards, just with a different load of P4 program that runs on those NPUs. These NPUs would either operate in line card mode or in quote-unquote fabric mode. So that essentially forms the decomposition of a modular system. Now, as we were looking at how do we enable SONiC on such a modular system which has multiple line cards, multiple fabric cards with multiple NPUs on each of these cards and the different route processor. There were two fundamental ways in which we basically looked at the SONiC enablement on this. Right, the first one, which I'm not showing on this slide, but just to verbally describe it, is a model where you abstract the entire chassis as a single forwarding element, and only one instance of SONiC runs on the entire system, and then the software below that, the vendor software stack or the platform software below that single instance of SONiC essentially abstracts out the entire system from SONiC. So SONiC basically views the entire system as one NPU or one instance of the ASIC. And the platform software basically deals with how to distribute the necessary information onto different line cards, how to program different line cards and different fabric cards as it typically happens in a traditional modular system. One of the challenges that we found with that model is that there is still a significant portion of vendor software stack that runs on those systems. And it also doesn't provide the necessary visibility into what is happening as packets are getting forwarded through the line cards and the fabrics. You know, what are the different drop points? What happens during congestion? How do you monitor that? How do you monitor the drops within the system and so on? Right. So which is very fundamental for enabling SONiC in such a system. So the model that we actually ended up with is one that actually mimics a leaf spine network within a chassis. And what I mean by that is, as I was explaining just a few minutes ago, if we basically decompose a chassis, it essentially looks like a leaf spine system, right? So we model SONiC in the exact same way, where every line card basically runs one instance of SONiC, and the entire fabric, like with the route processor CPU, and the entire fabric essentially becomes a second instance of SONiC. So now each of these instances of SONiC is managing multiple ASICs within that particular sheet metal, if you will. So each line card basically runs an instance of SONiC with support for multiple ASICs. And the route processor, each route processor basically runs an instance of SONiC managing a subset of the fabric card NPU. So this becomes like multi-NPU SONiC and multiple instances of those multi-NPU SONiC running in the system. So to add a little bit, or to view this in a slightly different way, so this is another visual way of looking at how this entire system looks like, right? So I just drew a enclosure around each instance of SONiC in the system. So every line card has one instance of SONiC managing the NPUs on that line card. And there is one instance of SONiC which runs on the route processor CPU, which manages all the ASICs across all the different fabric cards, right? So now this model brings a few pieces of, it actually bubbles up a few design elements. So the one design element is each CPU basically runs a unique instance of SONiC, and there is a localized management of that particular node with respect to SONiC. So for example, every instance of SONiC manages the platform. It not only manages the ASICs on that line card, but it also manages the platform components like your sensors, power supply units, fans, optics, LEDs on that particular line card. And for a different line card, a different instance of SONiC does that management, right? So there is essentially a complete visibility within the chassis, as if very similar or almost equivalent to the visibility one would have when SONiC is run on individual nodes within a leaf-spine network. The other thing that this also brings to the table is, and especially as I was mentioning earlier in the Cisco 8000 family, the NPU that runs on the line cards is the exact same NPU that runs on the fabrics with a different P4 load. So in a traditional chassis-based model, the P4 load that runs on the P4 software instance that runs on the fabric NPUs basically operates these NPUs in a VOQ mode, if you will, which will basically forward packets based on the virtual output queues. But given that it is the exact same NPU, in this model, when we are running SONiC in the disaggregated model, we basically load the same P4 load on the fabric NPUs as the P4 load on the line card NPUs, which basically implies that now it is a entire Ethernet-based fabric. So the VOQ-based fabric essentially now transforms to an Ethernet-based fabric, exactly mimicking a traditional leaf-spine topology, but within a chassis enclosure. So it has, basically we can translate it to either run in a full Ethernet mode or in a VOQ mode, because each of those has their own pros and cons, which again I'm not going to go into on this call. And it also gives the ability for full packet and byte counts at every point in the network in this chassis, including at fabric NPUs, because now all these internal links are operating as standard Ethernet links. So we can do traditional packet counts, byte counts, regular filters like any 5-tuple based filters on these NPUs, packet mirroring function. So essentially this basically models a typical leaf-spine system at this point. And in order to enable the multiple NPUs within a single form factor or within a single instance of SONiC, and this is the work that is already being done within the SONiC workgroup, which is to support multiple instances of multiple instances of BGP per SONiC instance. So every instance of NPU would have its own BGP instance, programming the appropriate prefixes and the next hop information within that. Now, one additional simplification that we are looking at. So in a normal in a traditional model, basically every instance of SONiC would be running BGP, and every peering here would essentially happen through BGP, as is done in a traditional leaf-spine system. However, what happens in that model is, given that the instance of SONiC that is running on the route processor is controlling or managing a large number of ASICs across multiple fabric cards, and this is typically because, like, if you look at any of the chassis-based deployment designs, the fabric cards typically don't have any CPUs because of the cost and power and functionality reasons. And the fabric NPUs are managed by the CPU of the route processor. So in this particular case, the instance of SONiC that is running on the route processor typically ends up having to manage a very large number of ASICs or NPUs on the fabrics. So running so many instances of BGP, it's still feasible, but it just makes the memory and the compute and the scale requirements much higher, because every NPU has to run its own instance of SONiC. So from a simplification standpoint, the one model that we are actually proposing and working on is, rather than creating a multi-hop environment with each hop running a BGP instance, we're essentially proposing a model where the fabric NPUs basically provide a virtual point-to-point connection across all the line card NPUs. And this cross-connect model can either be realized through standard VLANs in a Ethernet-based fabric, or they can be realized using VOQs in a VOQ-based fabric. So whether the Fabric NPU is configured, whether these links between the line card NPUs and Fabric NPUs are configured in standard Ethernet mode, or whether they are configured in a typical quote-unquote Fabric mode, the Fabric NPUs would always be switching the packets through a virtual cross connect that they are providing across the line card NPUs. So what this model enables is it completely removes the need to run BGP on the SONiC instance that is managing the Fabric NPUs. And this SONiC instance essentially becomes very simple because now it's just creating these point-to-point cross connects across the NPUs or the ASICs that are running on the line cards. And the BGP instances that are running on the line cards now will form direct peering relationship with the BGP instance running on the other line cards, or with other BGPs that are managing the other NPUs within the same line card. So essentially, think of this like where the Fabric is creating an Ethernet switch, quote unquote Ethernet switch, providing these point-to-point connections, and the line card, the BGP instances that are running on the line cards are basically talking directly to, they're talking to each other directly over this virtual Ethernet fabric, if you will. But even though this Ethernet fabric is providing VLAN-based cross connects, because this is still in traditional Ethernet mode, since this is still a regular Ethernet connection, and it processes regular Ethernet packets. Things like packet and byte counters, mirroring, ACLs, filtering rules, and all of those can still be provided. The other thing that can also be modeled in this mechanism is if depending upon what sort of buffering requirements are needed, deep buffers can either be provisioned only on the line card NPUs and only those become the buffering and queuing points, or the Fabric NPUs can also be enhanced by plugging in an additional HBM component, and now we can also start to do deep buffering on the Fabric NPUs, and it's a very use case by use case dependent discussion. Right. So that kind of concludes what I wanted to mainly bring to this forum. Just to kind of summarize, it's primarily around the design that we are working on to enable SONiC on large modular systems by mimicking a traditional leaf spine design within a chassis-based system, and yet provide all the same Ethernet capabilities at every point within the chassis for packet forwarding and packet monitoring capabilities. Right. I think we have another 7 minutes, I believe, so can take any questions or any comments.
Yeah. Hi, this is Sunanda from Selector Software.
Hey.
Hey, I have a question on how do we expose these SONiC instances that are running on the line card, on individual line cards, as well as the route processors to the external world? So will we be able to establish a GNMI session only to one line card? And how do we publish all of this information from a chassis point of view?
That's a very good question. So what I did not go into the detail again, mainly because of the lack of time is, but let me go to this slide and just answer your question. Every CPU in the system essentially has an external connection or a path to the external world. So what it means is there is a Ethernet switch. There is an Ethernet switch-based network within the chassis, which basically provides, think of it like a management connection to every CPU. So an individual GNMI session can be established to every CPU in the system. And by virtue of that, every SONiC instance can actually talk to the external world as an independent entity. There is no dependency of any SONiC instance running on the line card. There is no dependency for that to be dependent on the SONiC instance running on the RP. I mean, obviously, we need the SONiC running on the RP to come up, because there are some common chassis components that it needs to bring up before the line cards can be brought up. But once the line cards are brought up, and at that point, every line card can essentially come up on its own and have its own SONiC instance instantiated, upgraded, configured, and monitored.
Okay, thank you.
Does it answer your question?
Yeah, I have a follow-up question. So, what is the rationale of having a chassis, a physical chassis, when all of them are individually monitored and managed? And the second part of the second question is, will there be an alternate management of these line cards, or we are managing only through SONiC?
Yeah, so let me answer the first one. So the first question, if I understand, just to paraphrase, is why do this in a chassis when every instance, when every line card is managed as an individual SONiC instance, right?
Correct.
So, right. So if you look at it, there are two modes in which these networks can be designed, right? So and the main reason for why to look at a chassis-based system is the port density that it offers in a single sheet metal. Now, obviously, the same port density can also be realized by replacing a chassis with a leaf spine network, right? So every chassis can essentially be replaced with a leaf spine network, and you can still realize the same amount of port density. However, what the chassis-based system brings to the table, and this is where these systems have been traditionally used, is the economics of building such a port capacity, right? Especially given that the power supply units and fans are shared, and the fact that the internal connections between the line cards and the fabrics are now electrical connections as opposed to optical connections. It brings a certain set of economies to the table when that particular port density is delivered in a chassis form factor compared to individual boxes. And the second thing is now once a chassis is deployed, it essentially allows, and this may or may not be applicable for every deployment. So just bear that in mind, right? But once the chassis is deployed, it allows someone to either switch between running SONiC or running a traditional vendor operating system based on the role, right? So there might be some roles where there is a need to run a traditional operating system, like vendor provided operating system, but there might be other roles where there is a need to run SONiC or maybe migrate from one to the other over a period of time in either direction. So it's that flexibility that the chassis brings to the table. So to answer your second question, yes, there is obviously, like if you take at any vendor operating system, a traditional vendor operating system, it manages the entire chassis with one instance of OS, where the line card CPUs either run very minimal software or they run some part of the distributed software along with the software that runs on the other CPUs within the system.
Yeah, thank you so much.
Sure.
Okay, we have time for only one more question.
Hi, Praveen. This is Sabi from Juniper.
Yes.
I have a question. So in this scenario, like with the distributed SONiC architecture, there is still a need for a proprietary software, right? So that basically encompasses all the RE and the line cards into a single entity.
No, you're right in the sense that, like, even if we take a system on a chip or a fixed form factor, there is always some amount of platform software, right? Vendor provided platform software that integrates into SONiC to provide to basically provide the access to the different platform components, initializing those platform components, reading the sensor data from those platform components and providing it into SONiC. So yes, so similar to how there is a platform plugin, similar to how there is a platform plugin in a fixed form factor system, similar platform plugins exist in a modular system also to basically provide the necessary software to bring up the system and create the necessary infrastructure for SONiC to be instantiated.
Okay, thank you.
Sure.
Thank you, Parveen. With that, we are going to finish this presentation and move to the next one.
Thank you, everyone.
Thanks. Yeah. Before transition, I will just show the next one is from Dell. Introducing the SONiC management framework. I will make Centel the presenter. Again, because we have a lot of people getting rejected to enter the meeting. If you are enterprise people, could you please group together and join the meeting? 1 second. And one very important thing is for the people we make you as the organizer, when you exit, please just exit for yourself. Don't hit the button of exit for all. That will close the meeting. Appreciate that. Yeah.
Still, I'm not got the. I've sent you a request again. It says presented, but I haven't got the option to enable it. I've requested you.
I saw 2 Centel. Sorry, I apologize.
Yeah.
Okay, great.
Okay.
We are able to see.
All right.
Now. Yeah.
Yes. So let's start. So first of all, good morning, good evening, good afternoon to everyone of you. Thank you for attending this conference. And let me introduce ourselves. I'm Jose Gonzalez, a product manager at Dell Technologies. And
I'm Sanil Ganesan, architect at Dell Technologies.
All right, and this session is going to introduce you to the new work stream under SONiC for what we call the management framework. And we're going to explain you some details briefly about the thought process of the management framework. And as well, we are going to give you, next slide please. We're going to also give you some technical details on the management framework, all these activities that we are doing. So the first thing that we want to discuss is the thought process. So why a management framework is needed on SONiC. And experience from how organizations deploy fabrics into production, one of the requirements is automation, ease of use, simplicity, in order to achieve operational efficiencies, okay? So, and that requires a level of management built in on any system, right? And we also think that any management framework should support use cases, existing use cases, as well as new technologies that come up in the recent years. If we look at, next slide please, if we look at the current management framework that SONiC has, the situation is that some organizations find it a little bit complex, right? Perhaps they find that there are too many choices, and sometimes choices or different approaches are not comprehensive. They are not holistic. You do some things through maybe the Linux shell. Sometimes people like to go to the database directly and manipulate the config.db.json file. There are other scenarios where you have to go to the FRR CLI and configure the FRR stack right there from their CLI. So there is not a unified or centralized framework. So it's a little bit pieces, and you have to understand the mechanisms, how each mechanism interacts or relates with the other mechanism. Obviously, when you have to configure or you need to export or back up the configuration, again, you have to go to several places if you want to provide the holistic configuration base, that makes configuration prone to errors because you may forget something, because you may not be an expert on every single way, let me put it that way. And even if you have the Python CLI, what we call the SONiC CLI, that also can be a showstopper for some organizations because it requires to be run as root. So organizations that look for simplicity, ease of use, automation, when they go to SONiC, they see that the current management framework or infrastructure has room for improvement. Let me put it that way, has room for improvement. So what we did is look at the problem and see how we could solve in a way that can be beneficial for the community. So next slide, please. And that is how this idea of the management framework was born. The idea is to provide a holistic, comprehensive management infrastructure for SONiC. Now, we made some choices, right? So, and the first choice is that we didn't want to break anything. So the management framework should coexist with existing methods, right? So we need to be backwards compatible, and that was a big reason for the management framework. So not force people to use the management framework if they are not ready to do so. Second thing is that we look at, as we said before, about the new use cases. And we know that SNMP has been for years, but nowadays more and more organizations are looking at more modern northbound interfaces. So the idea of embracing GNMI and REST for northbound interfaces was also something that we saw important in our choice. Also for IT administrators, we wanted to provide a holistic and familiar command line interface. So as a user, you also will have a console that will allow you to configure and maintain SONiC with a single pane of glass. So that's the objective, single pane of glass. And also not to try to reinvent the wheel with respect to data models. We were looking at what was available already, either through standard bodies or other type of standards that are becoming also very adopted in the networking industry, such as OpenConfig. So wherever there is a model that fits our needs, we will prefer open standard, OpenConfig data model. Else, IDF, else we will define a model that is available for the community as well. Okay? And following the philosophy of SONiC, is going to be containerized. So it's going to be a container in order to provide isolation with other processes that run on SONiC. And if you are paying attention to the community, you could see that the first version of the management framework was delivered to the 2019-11 build available on the community. So that basically was the thought process, introduction, the reason why there is a motivation to make an effort to implement a management framework that can provide ease of use, simplicity, automation for SONiC. And now I'll let Senthil give us some details about the technical aspect.
Good morning, everyone. So I'm just going to quickly brief you all about the management framework. For most of them, so some of them already these slides are familiar because this has been going in the SONiC management framework for quite some time. So when we consider the unified management architecture, there are three things as the main goal we put together, right, to get this management framework. One is to simplify both for the end user as well as the developer. That is the number one goal we had when we started doing this management framework. Right? Simplify the use case both for the end user as well as the developer. For managing the SONiC as well as whoever is developing the feature. So it should be really simple for them to provide a management not-bone interface framework. And then for the end user, it should be more DevOps friendly with the APIs as Jose pointed out. And then currently, if you look at the validations as part of the current config.db.json, the validations is the user has to be aware of all the schemas in order to properly configure SONiC. So this unified management framework provides the entire config validation, error feedback, as also the role-based access control. So the boxes you see in green are the components the developers will touch in order to, the rest of the components, most of the components in the code is being auto-generated. So when we say the developers need to touch, even that it's not via code, it's mainly via standard data models, via YANG objects. So today, when the user develops a feature, he is going to write a schema for the particular feature. So while writing the schema, its exact schema can mimic a YANG. So we have multiple options. So you can have a SONiC YANG or an open config based standards based YANG, right? Once you're having a YANG, you just provide it to the framework, which auto generates code for a couple of not-bone interfaces automatically. So if you're writing a SONiC based YANG, all you need to do is provide the YANG to the framework, and the framework takes care of the rest by translating it and then configuring and as well as the validation portion of it, right? Once you write the YANG, you get your not-bone interfaces of REST as well as GNMI. So if you want to additionally provide CLI, you need to write the CLI-based XML actioner and renderer scripts. The rest of the whole thing has been taken care by the framework. So the crux of the framework is basically the translate, which translates the incoming object to the corresponding SONiC schema and validates it and make sure that it's a validated config for the SONiC. So in order to provide CLI, we have used an open source framework called Clish. So if you want to write Clish, you will be writing your modeling language in XML and provide actioners. So the CLI sits on top of the REST framework today. So basically the CLI will invoke the REST endpoints to configure SONiC. And then the renderer scripts, which are written in Jinja templates, will fetch the information from REST and then renders the information for the user, end user. And then currently we have integrated FRR CLIs as well into the management framework. A disclaimer, so whatever I'm presenting here, the first pull request, as Jose pointed out, is already there as part of the previous release of SONiC. Some of them are yet to be released to open source yet, so we'll expect soon a pull request for this kind of features. So even the FRR as well as other features have been integrated into the SONiC CLI. So in order to enter SONiC CLI, you'll provide SONiC CLI as a binary, and then you will see a intuitive CLI interface where you can provision the features for SONiC. So one of the well-received features of SONiC with the management interface is the REST interface. So today, REST, it follows the Open API spec. So basically, when you feed the YANG has been fed to a PyYang compiler, which spits out an Open API specification, which is a modern specification used by most of the API vendors today. And then a generated REST server is also generated as part of the framework. So you should be able to go to the management IP of the switch/UI. Then you'll see all the supported models available for configuring SONiC. And then the Swagger client side API also is presented to you so that you can play around or you can automate. If you want, you can take this Swagger, the Open API specification into a Postman collection where you can do an entire workflow for configuration of SONiC. We support today 3 types of authentication in that: username and password based authentication, a Java Web Token authentication where you can initially request for the token and you can have a token based authentication going forward, or you can use a client based certificate authentication for all the 3 northbound interfaces. Right? And the last one is the GNMI based. So what we have done is we have enhanced the existing SONiC telemetry framework to add a new translip client, which takes in the model-based telemetry, what we supported OpenConfig or SONiC and based, whatever it is. So it will take the model-based telemetry, and we also enhanced this not only for telemetry to using to provision as well. So we have implemented all the GNMI specs. Previously, the old telemetry was supporting get and subscribe. Now we have supported set as well as capabilities. So if you're using a GNMI capabilities request, you should be able to see all the supported models in the SONiC, and then you can do a set calls using GNMI set using the same model information to update or configure SONiC. So everything has been unified into one framework. All the developers have to do is write a YARN. Most of the code is auto-generated for them. They immediately get their GNMI and REST endpoints. If you need CLI, you can write the XML models. For the end user, they get a DevOps-friendly northbound APIs as well as intuitive CLI. They are familiar. The enterprise customers are already familiar with. So we also support enhanced the subscription mode to have a polling once and on change as well. And we have defined a new subscription mode called target defined, which will help you to define, which helps the customer end user define whether the model supports an on change or a sampled one, and what is the interval supported. If the user don't have to figure it out. If they say target defined, it's automatically calculated inside the framework to tell you for this object, on change is better, like an interface up down, or if you're looking for counters, a sampled is better, and what rate you can sample at the minimum rate. And last, so this is a new framework we introduced, the GNOI support as well as part of it. So GNOI provides the network operation interface for all the operation related activities. So with the framework has been just defined, and currently initially as we supported the management framework with some sample features, now we are supporting GNOI with some sample features. The upcoming pull request will have more feature sets added to the GNOI as well. Today we support image management, show text, copy config, and system time as an RPC for GNOI. Right. The main call to action is, I know everybody is developing new features in SONiC. It's a vibrant community. So start using the new management framework, which will help you anyway you're defining the schema. It's exactly same as a SONiC can. If you define it, you will get your both the northbound interface for your features. And join the SONiC management work group. If you have any questions, if you need any help or support related to any of the management feature, how to implement it, and provide your feedback on the management framework so that we can improve upon the same framework. The phase 1, as we talked about earlier, it's already merged and available part of the previous release of SONiC. The phase 2 is prepared for the pull request. You will see the additional features, GNOI and RBAC landing into SONiC shortly. That's about it. Any questions?
Okay, good. Maybe you can go. There are questions there on. Chat.
Hi, I have a question. This is Stefan from Google. I was wondering, what are the open config models that are currently supported, and what sort of support is planned?
We can provide you a list, follow-up email on the list of supported open config models. We are trying to go open config first. So whatever model is already available in OpenConfig, that is what we are trying to primarily target. If model is not available, we are defining our own. We are trying to contribute back to OpenConfig community. We are in touch with Google as well, to working with them to get the new open config models and enhancing it as well. I can send you a list after this session in the mailing list.
I think that's important to underscore. Some of the data models that we are introducing for SONiC, we are also working with the OpenConfig community to integrate those under OpenConfig. So for now, they will appear as SONiC models, but eventually, or that is our hope, is that the OpenConfig community will accept and adopt them as well. So they will become standards, our contribution for SONiC and OpenConfig at the same time.
Great, thank you.
Sendel, I just pasted
the OpenConfig games that modules that we support.
Anand?
So I just pasted in the chat window all the OpenConfig modules that we support.
So you are breaking up. Can you please repeat?
He's saying that I think Anand is trying to say that the models which we support is there in the project Arlo GitHub. Is that what you're coming at, Anand?
No, I just pasted all the modules that we support in the chat window.
Okay. Thanks, Anand.
Okay.
Yeah, as we said, what models Anand has posted here is not there in the community pull request yet. What is there is OpenConfig interface, and ACL is what the initial sample feature we have open source that has been merged into SONiC. You can expect to see much more OpenConfig support in SONiC.
Yeah, I asked for this is Li Hua. I asked for the community. Then what's the Dell's plan and timeline to make all the modules available?
Yeah, we are preparing for the pull request, for the next set of pull request. Yeah, on that.
So Liwa, we need to support Docker layer as you wanted, and a few of the other comments that we got, like Go module implementation. So once we have all that, we'll start raising the PR. So that is the whole idea.
Thanks.
Okay, any other questions?
If there are no other questions, thanks for your time, and we appreciate using the management framework going forward.
Yeah. Thanks, Dell team. Yeah, thank you. So we are ahead of our schedule. The next one will be from Broadcom. Bhaskar will talk about Broadwheel, enable advanced telemetry for all networks. Let's give it a pause for 5 minutes. Again, that we will start at 11:30. Again, and ask to the attendees that if you are from one company, please group together to join from one line. We got a lot of requests during the meeting that someone would like to join, but it already hits the capacity of 150 people.
Xin, is this 150 limit? Is that a Go meeting limit, or is this something that we as host can adjust?
Go meeting limit. Go to meeting limit. This is, yeah, it's the bridge limit. Hi, Bhaskar, are you there? Hi, Bhaskar. You are muted.
Yeah, I was trying to unmute and it won't let me unmute. Okay.
Okay.
Can you hear
I
me?
will make. Yeah, we can hear you now very well.
Okay.
Let me make you the presenter.
Yeah, I received that presenter request. I will start presenting at 11:30.
Okay.
I'll be back in 2 minutes. Okay.
Then I will present the schedule. Okay.
Yeah. Thanks.
If Dell team is still online, there is a question asking, what language is the management framework written? Is that in C++ or Go or anything else?
It is in Go.
Thank you.
Since we have a few minutes, maybe if people have questions about the previous presentations and want to chat about it, we can probably use this 4 minutes.
Yes, we could. Yeah.
Yeah. Basically, free flow time.
Let me ask OCP, if Michael, are you still online?
Hi, Shin. Yes, I'm on.
Great. May I ask where this will be posted? Will be in the SONiC wiki, or it will be on the OCP like a workshop, or?
So Shin, we're planning on putting this both on the wiki and then also on the OCP website under the past events page. Hope to have all these up later this week.
Okay, great. Thank you.
Hello? I have questions for the framework. Actually, this is Shu from LinkedIn. I know that like FRR actually has some young models, right? Those defined like in the new releases.
Yeah.
Is there any like alignment here, or is we just going?
No, currently we are not using. We started checking it out the FRR based Yang models, but it didn't align with the current model, which SONiC schema. So what we have used is the open config BGP network instance modules. As we said earlier, we try to align everything with standard based approach. We used open config network instance models and translated those to a schema. So you will be seeing a full-fledged BGP schema in the config.db.json as well once this pull request is ready, are in.
Okay. So this Clish based like CLI is probably like very different than the FRR video SH, right?
Yes.
Okay. Okay. Thanks.
Okay.
Okay, now it's almost time. I'm going to make Bhaskar as the presenter. Hi, Bhaskar. We are able to see your
Yeah, do you
screen.
see my screen?
Yeah, we are able to.
Are we ready to go?
Yes, let's go ahead.
Hello everyone, my name is Bhaskar Chinni. I'm product manager at Broadcom, responsible for telemetry solutions. Today I will talk about some of the use cases that are very key to be it the data center networks or enterprise customers. And I will connect them to the features that Broadcom is offering in our silicon, and how we are enabling those through the specification work that we are driving at SAI forum, SAI specification. So first and foremost is the latency monitoring and packet path tracing. This is a use case that many of the customers are already using for many years, but they are using at a different level of granularity. What we are going to, what we have now in our silicon, latest silicon Trident 3, Trident 4, JCO 2, etc., is a granular capability to provide packet level latency monitoring and ability to trace packets at
Sorry, are
or path
you
level.
sharing anything?
I am.
I don't see the slides, and I guess I'm not the only one.
Yeah, but Bhaskar, it's all blank.
I'm able to see the screen, and many people cannot see the screen.
But the screen is not moving at all. It's not doing. It's still on the very first page.
Oh, that's a difference.
Okay. How about now? I am in key telemetry use cases slide. Do you see it?
Hey, Bhaskar, we're actually still seeing that first title slide, and I think that's because you went to presentation mode, which is likely showing on another desktop. We're still seeing.
No, I only use one. I only use one desktop, so the problem cannot happen on my laptop.
You might want to try sharing your whole screen rather than just the application. The presentation mode shows up as different application.
A few of us actually only see the green screen, not even the first slide.
Now it's completely gone. Do you want to try again?
I'm using the browser. I don't see
again.
anything.
This screen is. I stopped sharing now. And I'm trying to share again.
I don't see the image. No
I stopped
presentation
sharing.
is visible.
Yeah. I am trying to share again. Please bear with me a minute. Shin, the screen sharing icon is rotating. It's not giving me any control.
Okay, let me give you again.
Okay.
Huh. You are a presenter / organizer now. Are you able? Hi, Bhaskar, are you able to share? Hi, Bhaskar. I will ask Rita to help to share the one you share with her. Can you hear us, Bhaskar? Hi, Bhaskar, we cannot hear you.
Hello? Shin, can you hear me?
Yes, we can hear you. And we are asking Rita to share the slides from you. Can you just, she will advance, just let us know when we should go to the next page. Can you see the screen?
Yes, and now yes.
Hey, Bhaskar, seems we keep on having issue with hearing from Bhaskar.
First of all, so how about all the other audience? Are you able to see the screen now?
Yes.
Yeah. I can see it, Jim.
Okay. Okay, great.
Hey,
Oh,
wait,
can
it's
I?
gone. It's gone again.
It's done.
Looks like Bhaskar.
Oh, I thought I was trying to.
Yep.
Okay, Shin, you can share the screen.
Yeah, you can talk through. We will ask Rita to share the screen.
Okay, sounds good.
The screen is gone right now.
Yep. Rita's gonna
Coming
pull it
back.
Yeah, please reshare again. Okay.
Okay.
Okay, so we are on the right screen now. Key telemetry use cases. Can everybody see that slide?
Yes.
Yes, Bhaskar, we can see it. You can take it over.
Bhaskar, looks like you muted yourself. Can you please unmute? Bhaskar, you're currently on mute.
Hey, can you hear me now?
Yes, we can hear you. You can take it over.
Okay.
And you're back on mute. I'm not sure what's going on with your audio.
Hi, Bhaskar. Seems like you have audio issue. I might need to make a change before you resolve the audio issue. Let me ask Ben, is there anyone from Broadcom to speak for this?
No, not really, Jin. I'm trying to contact Bhaskar and maybe get him in the same room as that we're in, so he can do it here, because there's clearly a problem here. But no, there's nobody else ready to run the presentation.
Okay, so let's give it 1 more minute. Yeah, if Bhaskar cannot, let me ask Praveen from LinkedIn. Are you able to present?
Yeah, hi Shin, this is Praveen. Yeah, I can present if needed.
Okay, great. Let me just
consider as humans. Yeah, sure.
Yeah, thank you. Yeah.
That's weird. That's a Raleigh number. Doesn't make sense.
Bhaskar, if you're able to hear me, I'm going to dismiss you from the call. Please rejoin, and we'll see if that fixes your audio issue. If so, maybe we can finish up. So Shin, let's give it maybe one more minute to see if Bhaskar is able to rejoin, and if that fixes his audio.
Agree. Thank you.
Sorry, guys, the slides are not visible.
Vitali, we have an audio issue. We are asking Bhaskar to rejoin. Yeah, please stay tuned.
I just spoke to Bhaskar. He wasn't aware that nobody could hear him, so I think he's been presenting away. So he's going to try and reconnect.
Okay, thank you.
Can you hear me?
Yes, we're able to.
Okay. I don't know what's going on there. Let me quickly share the deck. Do you see my screen?
Yes, it's working now. Thank you.
Okay,
Yes,
great.
now
So
we can see.
okay. So I was talking about for 3 minutes. Thanks to Ben, he called me and I wasn't sure what was going on. Okay, so I was talking about the ability to monitor latency in a granular way. That leads to many interesting use cases. I'll explain why and how we are going to do that. And then congestion monitoring, there are many scenarios, be it microburst or consistent oversubscription. Broadcom has tools to make it easy. You can still hear me, right?
Yes.
Yes, we can. Keep going.
Okay. Yeah. So then packet drop monitoring is another scenario where a lot of the times it's not easy to troubleshoot simply because the application will not know that the packets have been dropped, and B, even if the packet was dropped, it is very difficult to troubleshoot. So Broadcom can provide very good visibility to that kind of scenarios. Elephant flow monitoring is another use case where a lot of the enterprises will benefit by understanding how many elephant flows they are having in their network, and when they are active, how is it affecting their bandwidth consumption, etc. Will greatly facilitate them to optimize their network. The other one is enhanced policy enforcement and security. This is like a mainly IPFix use case. If you have the ability to get a granular or an aggregated flow statistics, then that will facilitate to better enforce the policies, be it user level consumption or identifying the flows that are not supposed to be there will help security scenarios as well. I'll also talk about scalable telemetry gathering without involving host CPU, because host CPU resources are very important for protocols such as layer 2, layer 3, etc. If the chip itself can stream data, metadata or telemetry reports to remote collector, that greatly enhances the performance of the network. Overall, many of these use cases can facilitate the traffic engineering application. I know some of our MSDC customers, they use traffic engineering, and they are today using a more coarse data and leveraging this new level of visibility will greatly enhance those traffic engineering applications and provide more responsive network to the customer and use cases. All of these use cases, what we are trying to do, we started this journey a couple of years back. With the support of the community, we defined telemetry and monitoring TAM specification, and some of the use cases are covered, and I will mention in the following slides. So now I am in band flow analyzer slide. I hope you all can see that. So in-band flow analyzer is Broadcom's implementation of the in-band telemetry technology. What is in-band telemetry? Just to give you a brief introduction, traditionally people use SNMP type of technologies or IPFix type of technologies to gather aggregated statistics, aggregated packet reports, aggregated traffic reports out of band, right? Like you talk to the CPU, you get a report, and then you do it at a certain frequency. Sometimes SNMP is used in a few minutes of interval. Sometimes IPFix is used at a more frequent interval. The in-band telemetry is it uses the user traffic to embed the packet processing data within that data plane packet. So host CPU is not involved. The data plane itself, or some people call it as a forwarding path, the data plane itself will add user the traffic processing related metadata to the packet and then send it off. And it happens in a cumulative manner. So let's say the server has sent a packet. The packet goes to, let's say, the first switch that I am showing as a thread for here. It will add its own metadata. And then it goes to the second switch, and then the second switch will add its own metadata in a cumulative manner, meaning the second switch will have two sets of metadata identifying the two hops the packet went through. And then finally, when it goes to the last node, the metadata is extracted. The last node removes that metadata, creates a separate report, and sends it to the collector application. The original packet goes to the application unmodified for telemetry purposes, at least, to the remote to the server. This is the case where we have where you are adding or you are gathering in-band telemetry metadata for live traffic, right? There are other use cases as well, such as probe packets. Sometimes it may not be advisable, because if you have gigabits of traffic, then you don't want to add metadata to every packet, otherwise it will explode the application. So you could use a cloned packet that can be sampled, and that packet gets metadata through the network, and then that will send the report to the collector application. That is another way you can scale the in-band telemetry technology without losing the ability to collect the packet level metadata. And depending on the metadata that the reports gather, there are several use cases possible. Because the latency monitoring is one key use case, the metadata includes what is the ingress timestamp and the egress timestamp at each hop. That means you will be able to analyze how long the packet has spent at each hop the packet went through. So that's a great way to provide visibility to application and take action if required. Another use case is packet tracing, right? Sometimes, most of the time, the packets pass through the network in a predetermined manner. Even if you have ECMP, the flow, for a specific flow, it results in a specific hash, and that takes one aggregation group member, and it always travels that way, unless you are using some weighted weighted distribution, right? So if a packet suddenly changing a route means it is possibly because a port went down or something happened in the network, thereby the packets are taking a different route, and that will be an alert that can easily and quickly go to application, so that you can the application either automatically or user driven manner take corrective action. So all these use cases, again, we're talking about at either packet level or flow level, providing, enabling many new use cases and optimizing the network. Right. Second feature I'm going to talk about is the mirror on drop. This is about providing packet drop visibility to the application. Many of the times, right, the packets get dropped either silently, or maybe it is happening once in a while that it is not being captured by the traditional applications. Then what happens is when you have these kind of problems happening, the TCP window, because it's connection oriented, it will have to retransmit, and when you have more sensitive applications like RDMA, etc., then the application performance gets affected. And sometimes it affects the user performance because maybe it is one user that is trying to make a purchase on an e-commerce website, and then the transaction got affected and you lose the customer. And the worst scenario is nobody knows. The application doesn't know, and it is not easy to troubleshoot. This mirror on drop feature provides immediate visibility, like real-time visibility, when a packet drop happened. Let's say a packet got dropped, let's say for VLAN translation error. Then the silicon itself will send a copy of the packet along with the drop reason to the remote collector application, and that means you're not losing. You can easily, because you are getting a copy of the packet, you can easily identify what type of flows that are getting affected and why that packet got dropped, and then the application can take corrective action. There are two modes here. One is stateful and stateless. What do I mean by that? Stateless is like whenever a packet drop happened, the silicon sends a copy of the packet along with the drop reason, the application receives it. So there is no state in the silicon. It's just whenever it happens, the information is going to the application. In a stateful scenario, what happens is the silicon starts tracking those flows that are experiencing packet drops. So whenever the packet drop happened, it will send a copy of the dropped packet and it starts monitoring. And if more packets are getting dropped for the same drop reason, it will not send duplicate packets to the collector application, because otherwise the collector application will get overloaded. And whenever the packet drop stop, let's say after a configurable or configured time interval, could be 5 seconds, whatever the user configured, if the packet drops are no longer happening, then it is perceived that packet drop stop for that flow, and an event is sent to the collector application. So that is a stateful monitoring, where the silicon is maintaining state and reducing load on the collector application and informing when the packet drop started, how many packet drops happened, and when the packet drop stopped. So this is a great feature where the stateful or stateless, whatever is applicable to the customer, where you get real-time visibility and then troubleshoot very fast. Right. So the other feature is flow tracker, IPFix. IPFix is a IETF standard, where it is an out-of-band technology, where the silicon or the network node maintains an aggregation of statistics for a flow criteria. So you could say, I want to monitor all the flows from a particular source IP to a particular destination IP address. Then the silicon will build a table matching all the flows that are defined by the two-tuple criteria by the user. And then periodically it exports that flow table data to the remote collector application. And there are, again, in this scenario, we took one example as a two-tuple, but it's a flexible criteria. Whatever user defined as a flow criteria, the silicon can build that flow table and then export periodically that flow data to remote collector, and also age out certain flows that are stale, right? That way, your hardware resources are better used for active flows. Can you still hear me?
Yep.
Yeah.
Yes,
Okay,
loud
great.
and
Yeah. So, what kind of data that goes into this remote collector application is how many packets are received, what is the bandwidth assumed, what is the timestamp, how long the flow is active. These kind of aggregated statistics is also useful in many use cases. So one clear use case is you want to understand what is the bandwidth consumed by various flows, and the other use case is forensics, right? Like maybe you're not supposed to have so much bandwidth used by a particular application, or maybe one particular user launching too many flows. All this kind of information will be useful to easily go into analyze better. What about the security? The security aspect is like sometimes what happens is DDoS applications, they launch too many flows, right? Sometimes they are like low-lying, like they are long-lasting flows. They are very small flows, but they last longer. So those kind of flows you can easily identify because you have visibility into those flows, and then you can take corrective action. So that is a security use case. The other use case that I discussed earlier was the elephant flow monitoring, right? A lot of the times what happens, elephant flows, I mean, just to explain what elephant flow is, right? These are long-lived flows. Think of like a 4K video getting transmitted. That is an elephant flow. A storage writing is another good example of an elephant flow. These are like a long-lived flows, and they consume a lot of bandwidth, and they are not latency sensitive, meaning even if a packet or two gets dropped, they can be easily, the application does typically some buffering and all, so they can easily recover from that. Whereas mice flows can be like a BFD is one good example of a mice flow. These are like a very short-lived, very quick, latency sensitive. If you miss 3 packets in, let's say, a few milliseconds, then the link is considered bad, and then rerouting and all sorts of things will happen. So the certain mice flows are very important, and they need to be addressed in a very time-sensitive manner. If you put unknowingly elephant flows and mice flows into the same queue, then obviously mice flows will starve of resources because elephant flows will be hogging the bandwidth. So and that kind of scenario becomes very important to monitor and take a quick action. Our silicon can take corrective action, but again, it is all it depends on the applications scenarios, because sometimes that may not be recommended that silicon take automatic corrective action. But at least it can identify how many flows are elephant and what kind of bandwidth they are consuming, when are they active, and that way application can take corrective action. All these things is happening in the hardware, right? Like host CPU is not involved. That's the key difference here. Because the hardware itself is building the flow, hardware is learning the flows, and hardware is exporting the flows, it results in a very high scalable network node performance overall, because your host CPU can allocate the memory, the CPU cycles for other things like layer 2 and layer 3 protocols. The other use case is streaming telemetry. It is a generic term. I know like GNMI also does streaming telemetry through host CPU. So it's a generic term, but the specific focus that I would like to bring your attention is hardware-based streaming. The hardware itself can stream telemetry reports to collector. And because the hardware is doing it, it can access any metric that is available in the pipeline. I give some examples like MMU stats, flex counters, etc., but it can be any statistic that is available to the pipeline. And it can do encapsulation, like protobuf is one example, but it can do thrift or other encapsulations as well. And the hardware periodically encapsulates, gathers the data, encapsulates it, and exports it in a report to remote collector. And that means you no longer need to use SNMP or whatever type of technologies in a very coarse manner, and you can gather any metadata from the switch in a very highly scalable manner. Like it could be hundreds of milliseconds, and you gather that data and you process that data. And again, this is happening in the hardware, not involving the CPU. So some of these features, like for example, IFA was already addressed in the TAM specification, and mirror on draw framework was also addressed in the TAM specification, some aspects of it at least. We would like to work with the community to bring in the remaining features as well. Of course, it's always evolving scenario. As and when we find a new use case, a new key feature that we can deliver through the silicon itself, adding value to the network performance and optimization use cases, we'd like to bring it to the community and work with the community to update the specification. And so I'm giving two links here. One is for the TAM specification that is already published, and also the agent specification. It's again a reference agent. For SONiC, I think Broadcom has already contributed a REST API that would be exporting from the management framework, like Dell mentioned before, and that way we are good. But for even other any SAI based network OS can utilize the REST API and then export it to the collector applications easily. So that is all I have for today. I'm sorry about the glitches that we had at the beginning of the meeting. Any questions?
Hi, Bhaskar. This is Sunanda. Yeah.
What company you are from?
I'm from Selector Software.
Which software?
Selector Software.
Okay, hi.
Yeah, it's a very small company. So.
No, I know. I know.
Yeah.
I am working with Kannan on that.
Correct. So how do we tie these new metrics that you're monitoring with the Trident 4 into the SAI database? Will they translate into new data models that will be defined in SAI, or how do we do this compatibility with chips that don't support these kind of advanced telemetry?
So some features require chip support. For example, if you take in-band telemetry, it requires silicon support. So we cannot enable it on legacy silicon, right? If the question is about the supported silicon, how do we enable it? And I think the specification, the framework allows the silicon exporting mechanism, if I'm not mistaken. Ben can correct me. So we like to work with the community to expand this specification so that it goes into the SONiC implementations.
Okay, thank you.
Any other questions?
Hi, this is Jun Hui from Juniper Networks. I have just one question. What's the scale of the features that we support, for example, the flow tracker?
So the scale is you can go up to 120K or so. It depends on the silicon. So if I were to take Trident 3 or Trident 4 as an example, let's say Trident 3, I believe Trident 4 can do more. Trident 3 can deliver 120K plus. close.
Okay, thank you.
Any other questions? If no, before we take the break, let me show what we are looking at in the afternoon. In the afternoon, we will have 5 sessions. The break is from 12 to 1:30. We will have Praveen from Linking talk about developers overview. We will have Marianne from Mellanox talking about how to extend SONiC to adopt more application extension on the platform. Also, Arkady from Intel will talk about programmable data plane. The later session will be Vishal from Avis talking about vendor neutral support for SONiC solutions, and Dean from Keysight, it was Excel talking about SONiC performance and resilience test report.